Hi everybody, it's section 3.1, addition and subtraction of whole numbers. So we know addition, let's figure out subtraction also. I know when I was in elementary school, one thing I remember very clearly was doing piles and piles of worksheets where it would say something like 7 minus 2 equals 5 because 2 plus 5 is 7, and the 5 would be in a little box in both equations and you'd notice that they matched. And so that's really the definition of subtraction. A minus B equals C if A equals B plus C. The terminology is a little tricky. I would like you to at least recognize these, if not use them every day. The first number is the minuend, B, the second one is the subtrahend, and C is the difference, and you surely should use the word difference. So we had these properties for addition a minute ago about commutativity. Remember, that's order doesn't matter. Associativity, that meant grouping didn't matter. Identity was the identity preserver who always let the other guy get his way. And closure is the answer of the same kind I started. So you should right now stop this presentation and think about subtraction. Is it any of these things? So stop and think, and when you're done, go to the next slide. Well, I hate to be so negative, but no, 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 it's not any of those things. Subtraction is not commutative. It's not associative. It doesn't have an identity because the identity has to work in either order. And 0 works great when you put it on the right, but it does not work at all when you put it on the left. And subtraction isn't closed because although sometimes when you subtract whole numbers, you get a whole number, like 10 minus 6 is 4, and that's a whole number. But if I go smaller minus bigger, I am not going to get a whole number answer. So we say it is not closed under subtraction, because if even once you don't get a whole number answer, then it's not closed. Now, how do you teach subtraction? This is much more rich, and some of them are easier than others. So the missing addend is exactly the kind of paper handout that I explained earlier. I say 5 minus 3 is what? To figure that out, I say 3 plus what is 5. And the takeaway model is the second one, and that's the one everybody remembers. The clue of a takeaway is how many are left, how many remain, how many do you still have. Those kinds of verbal cues tell you you're using the takeaway model. And it says A minus B, you take A things, and you're going to remove physically B of them and count what's remaining. So things like eating cookies. I had 3 cookies. My friend ate 2. How many do I have left? The birds were on the clothesline and a certain number flew away. How many are left on the clothesline? That kind of thing. One that does occasionally confuse some 11 students is comparison subtraction. And that tells us that A minus B is what I need to add to B to get back to A. And a clue that this is really the model we're using. In a story problem, you'll see something that says how many more, how much greater than, those kinds of words. So here's a perfect example. Anne is 4 feet tall, Bob is 3 feet tall. How much taller is Anne than Bob? So you see that clue, how much taller. That tells me it's probably comparison. And it certainly isn't takeaway, as you can see on my slide. We do not want to chop 3 feet of Anne's height and measure what part is bloody and gross is left. That would be very cruel and would get us into a lot of trouble. So instead, what you'd probably do is stand Anne and Bob next to each other and measure how many feet from the top of Bob's head to the top of Anne's head, which would be 1 more foot. So that's comparison subtraction. Similar things might be I have $10, you have $14. How much more do you have than I have? No one's going to take away any of our money. We just have to think, how many dollars would they have to add to my 10 to get to your 14? Comparison, subtraction. And the number line model is pretty easy too. We are going to find 5 minus 3 by starting at the first number, just like we do with addition, but instead of moving to the right 3 when we subtract, we're going to move to the left 3. And where we stop will be our answer, which is called the difference. Fact families are very nice. It helps students remember facts more quickly and to relate addition and subtraction. And so you draw a triangle, you would put 3 numbers in the corner so that 2 of them add to the third, and you would ask the student what equations can they make from this family, from this triangle picture. I thought I'd throw in less than just because I don't want to forget. A is less than B if I can add a positive number to A to get to B. Notice that from the number line model, that says that A has to be to the left of B because I'm going to add a positive number, that is, move to the right to get to B.